We are going to let folks make their way in from the waiting room, and we will get started in just a moment. All right, well, welcome. Thank you to everyone who is joining us live for today's Lunch and Learn. What is up with the weather? Examining extremes of past years and how they relate to climate change. And thank you to everyone who is watching this recording on YouTube. Maine's climate is getting warmer and wetter, and the extreme weather patterns that can bring damaging rainfall and prolonged heat waves are becoming more common. But how does a warming climate produce these extremes? And why has the last year seemed so unusual? Summer 2023 was the second wettest on record after several dry years, and global mean temperatures soared to record highs. And I don't have to remind you about the major storms we have seen since December. We are delighted to welcome Dr. Sean Birkel today. He is the Maine State Climatologist and an assistant professor at the University of Maine's Climate Change Institute and Cooperative Extension School. Dr. Birkel will explore these questions with us and walk us through historical climate context and recent examples of extreme weather in Maine and what has led to these events. Welcome, Professor Birkel. My name is Kathleen Neal. I'm the Senior Director of Policy and Partnerships here at Maine Conservation Voters and Maine Conservation Alliance. Our organizations represent more than 13,000 members and supporters dedicated to protecting the environment and our democracy. MCA does that through education, collaboration, and advocacy, and MCV by influencing public policy, holding politicians accountable, and winning elections. Since 2020, this weekly online Lunch and Learn series has helped us advance all of those goals, creating a shared space to explore our environmental and social history, our policy priorities, climate action movement, and more. A few notes before we dive into today's program. We will hear from Dr. Birkel first and then tackle your questions in the Q&A session at the end. You don't have to wait, though. You can send your questions to me through the chat whenever they occur to you. I'll synthesize them and ask as many as possible during the Q&A following the presentation. If you have any technical difficulties today, you can message Maggie Summers through the chat and she will help you out. This event is being recorded and the video will be posted on our website later this afternoon. You can also find recordings of all of our programs on YouTube, where there are a number of playlists that can help you focus in on particular topics. Thank you all for joining us, and Dr. Birkel, I will turn it over to you.
Thank you, Kathleen, and good afternoon, everyone. Bear with me for a moment while I share my screen. Can you see my intro slide? Great, thank you. Well, good afternoon again. As Kathleen said, I am an assistant professor in the Maine State Climatologist, and I have a joint appointment at the Climate Change Institute and Cooperative Extension at the University of Maine. And the title on this slide is a little different than in the flyer. However, it's same content. I just couldn't fit that other title on the slide in a pleasing way. I thought that, especially in light of the recent storms in December and January, and the very several notable records worldwide and in Maine in 2023, I thought it'd be interesting to step through first an overview of climate change in Maine, some of the background information and the overall trends, and then to spend a few minutes on some of the extremes observed both here in Maine and globally in this past year. And also to dedicate a few slides and conversation to the storms December 18th, as well as the January 10th and 13th storms, to place those in a climate context, to discuss the weather aspects of those storms, but how there is a climate underpinning, and then to discuss how these sorts of events may become more frequent in the future, as well as unknowns associated with that. Now, I recognize a climate talk can often have a lot of doom and gloom. I'd like to end the talk on a brighter note, with some words of what is happening now in Maine with the Maine Climate Council, things that we can do in terms of adaptation mitigation. And so even though there is some difficult content and it can feel overwhelming at times, there are things that we can do, and we shall press forward and prepare for what comes in the years and decades ahead. And so I want to leave on an uplifting note. And also, if there's time, I'd also like to demo a couple pages on websites that I've developed. Climate Reanalyzer on the left, I've been developing since 2012 as a climate data visualization tool that provides access to an array of global climate model reanalysis and weather forecast data sets. And then as a state climatologist, I've developed the Maine Climate Office, which takes a subset of the information on Climate Reanalyzer and focuses it on Maine. And I also have additional resources from NOAA for short-term climate seasonal predictions, and Maine-specific weather station data and accessible charts, interactive charts. And so I'd like to show some of that if we have time. And also, I'd like to share with you recent climate reports that you may or may not be familiar with. I've been involved in developing the 2020 Maine's Climate Future Update Report, which was led by the Climate Change Institute at the University of Maine. And I'm also serving on the Scientific and Technical Subcommittee of the Maine Climate Council. And in 2020, we developed this assessment of climate change and its effects in Maine. And then in 2021, we produced a short climate science update report. And the STS, the technical subcommittee, is currently working on an update to the 2020 assessment report. And some of the information on these slides will be drawn from those reports. So first, with an overall perspective on changes in Maine's temperature and precipitation climate over the past century, a little more than a century. NOAA has statewide and climate division, as well as county level data going back to 1895. These data are synthesized from observational records and then put into what we call gridded data sets, so we can calculate statewide mean or climate division means. And based on those NOAA data sets, we can look at changes in annual temperature over time. And that's shown in the upper left. And below that is annual precipitation. Maine's climate is getting warmer and wetter. The overall annual temperature increase is about 3 degrees over the past little more than a century. And that's on a linear trend, but you can see that there's significant year-to-year variability. And you can also detect some decade scale variability. Likewise, in the precipitation signal, overall increase, but there's significant variability within that. The precipitation on an annual basis overall has increased by about 6 inches since 1895. And there's also, particularly in the last 2 decades, there's been an increase in heavy precipitation events that is commonly defined using daily station data, 2 inches or greater per day. There are other measures that can be used. And then, of course, we can also consider heavy precipitation events that occur in a few hours. that's something we'll discuss in a few minutes. Um, I I meant to mention that for the temperature increase, the overnight low temperatures are rising faster than daytime highs, and the last 10 warmest years have occurred since 1998. And now going back to precipitation, the projected increase in precipitation on an annual mean is on the order of 5 to 14%. And that's also in association with more heavy precipitation events. And now when we project into the future, and when I say project into the future, I mean using climate models that are initialized with real world, we call them boundary conditions, and then simulations that include the physics of the atmosphere and oceans. Simulations can be run in which the model has radiative forcings for greenhouse gas emissions, as well as for natural forcings such as volcanic eruptions and solar variability. And these models have been operated for the recent historical interval, and then they very well reproduce observed climate, and then they're used to project into the future for different greenhouse gas emissions scenarios. Now, on the left of the plot, the black line shows observed mean annual temperature in Maine, and the gray line here is an average of multiple model simulations. And then this cloud of results in gray is the spread of results from these multiple models. And then the future projections begin here, and you can see the three signals diverge. So the first scenario being a future of low greenhouse gas emissions, ranging to the more extreme scenario of high greenhouse gas emissions, which relates to no action taken to reduce. Now, we can't say with absolute certainty which track we're on, because of course there are societal choices both here, nationwide, and worldwide. But this at least provides us a physically plausible spread of possible outcomes by the end of the century. So having said all that, in general, that spread of physically plausible temperature outcomes is between 2 and 10 degrees Fahrenheit mean annual warming by 2100. And so Maine's climate could be significantly different in 2100 than it is now, especially with the higher end scenario. So now associated with this warming are changes to the mean annual temperature cycle, as well as changes in the precipitation cycle as well. But if we consider the statewide mean annual temperature cycle, we can compare a signal from the late 1800s into the early 1900s here in blue versus something more recent, 1995 to 2014. And these periods were chosen so it could be separated by a century. And then this particular figure, which is from Maine's Climate Future 2015, we chose to have a 2050 estimate or projection. And so over the past century, Maine's warm season has increased in length with respect to the 32 degree Fahrenheit line here by about 2 weeks. And so that the period of winter snow and ice cover is roughly two weeks shorter, and the warm season is 2 weeks longer. And that, of course, also ties into the growing season. And projected out to 2050, there's a comparable shift. And then it'd be beyond that for 2100 as well. I'm going to go to the next slide. And these two maps show growing season length for a 30-year recent climatology, 1991 to 2020. And this is from a gridded data set based on real observations. And then in the top panel, this is the high-end emission scenario for the year 2100. So just to give you a visual depiction of the shift in latitude that we're talking about here. By this analysis, the growing season length, and the growing season length is determined by killing frost in the spring and fall. So the average date at which that would occur under given climate conditions. And so, as you can see here, the approximate shift geographically, the conditions that are now present in, so we'll go to the top panel first, in the coastal and inland part of the Central Climate Division, that area in 2100, what is now the growing season conditions for this portion of Maine, that would be comparable to what New Jersey, Long Island region is today. That's what we might expect in Maine by the end of the century. So it just give you an idea of as the temperatures increase, there's this latitudinal shift, this northward shift of biomes as well as temperature, which has real impact on the growing season and the temperature annual cycle in general. And also in association with the warming climate is an intensification of the hydrologic cycle, and that relates to the warming ocean surfaces in upper levels of the ocean. There's increased evaporation, so there's an increased transfer of moisture from the oceans into the atmosphere, and the excess water vapor, that is then gives increased potential for heavy rainfall. There's also, it depends on the particular weather pattern that happens to form, but with a more humid atmosphere, there's increased potential for heavy rainfall. And also this is associated with changes in circulation that can link up to processes occurring in the Arctic associated with Arctic amplification. That refers to in the Arctic, in relation to decline of snow and ice cover that's being driven by warming temperatures from greenhouse gas emissions. As the snow and ice declines, more land and ocean surfaces are exposed that can then absorb more heat, which can exacerbate the snow and ice decline and exacerbate the warming in the Arctic. And then this feeds back into the circulation of the entire Northern Hemisphere. And so this is Arctic amplification. And the Arctic has warmed more than any other region on the planet. And as a consequence of the loss of sea ice cover, one thing to note is that anyone who's lived in Maine for a long time, for several decades, knows that September in particular seems warmer than it did 20 or 30 years ago. And when we look at the data, it's the most of the increase in the warm season has occurred in late summer and early fall, and in particular in September. And that relates to the loss of Arctic sea ice, because the minimum ice extent in the Arctic, which tends to occur around the first week in September, the area of ice cover has declined by close to 50%. And that means, and that implies, that the onset of Arctic winter is delayed, and there's also a shorter Arctic winter, a shorter time period for which really cold air masses can form. And so that has a direct impact on the climate of the middle latitudes in the Northern Hemisphere, including in Maine. And so the warming in September has this connection to Arctic sea ice loss. And we feel that with, it seems like summer extends pretty far into September now, and sometimes even into the first part of October, including this past year. In extreme weather, works into this. Yeah, first I would like to start off with it's important to at first we have to view weather events first and foremost as weather events, but weather occurs and develops depending on the underlying climate, on the boundary conditions, the present state of sea surface temperature, of atmospheric humidity and atmospheric winds. And so as the climate changes, the weather will also be a little different because fundamentally climate is average weather. So if there's a change in climate, the weather too will respond in some way. Now, for any particular event, for a storm or a heat wave, it's important to um, if we really want to understand the climate connection and the likelihood of that event happening in a particular under a particular climate, we'd have to do an attribution study. We'd have to examine the historical statistics and evaluate how likely it would be for a particular event to occur. And so in general, we are seeing more extreme events, events that may have occurred once in 20 years or once in 100 years are now happening more frequently because the climate is warming. And for the mechanisms that I mentioned, the intensification of the hydrologic cycle, as well as influence from the Arctic, that makes extremes more likely. In the Northeast region uh, has seen the largest increase of heavy precipitation events um, of anywhere in the country, and that relates to this region is at the intersection of air masses. It actually links into Mount Washington, um, how they world's worst weather. That relates to the intersection of air masses, systems that can be coming out of the Arctic, across from the Pacific, off the Gulf of Mexico, off the North Atlantic. And that is also why Maine's climate is getting wetter because the North Atlantic storm track places precipitation here. And but that also relates to we're seeing more heavy precipitation events. This figure here highlights that based on station data from Farmington, a long-term record. And this is from Maine's Climate Future 2020 update. These bars here, they're in 10-year bins. They represent the average total precipitation for different categories of rainfall totals. So for example, this shade of blue, 0.5 inches, and then a darker blue, 1 inch, 2 inch, and 3 inch. So they're the average daily precipitation event thresholds. And the in this bin that's centered on 2010, you see that there's the largest number of 1 inch, 2 inch, and 3 inch per day rainfall events. And we see similar trends in other records as well. Carrying on the theme of extremes, in addition to heavy rainfall events, um, the large-scale patterns that are often associated with these, and again, at the weather time scale, we can often find analogs in the historical record, but it's a matter of certain extremes are becoming more common. This example is from late October, early November of 2019. And as you may recall, in the fall of 2019, there were two damaging windstorms that impacted Maine within a couple weeks of one another. The first impacted southern Maine the most. That was in middle of October. And then a couple weeks later, central Maine was impacted. But the latter event was associated with this wave meander in the jet stream that was also associated with extremes happening on the other side of the continent. In the news at the same time, as we were impacted by a damaging windstorm, California saw record or near record wildfire activity that that was, and the fire was being fanned by strong Santa Ana winds. Now, I believe this fire itself was caused by sparks from electrical equipment, but the intense winds um, uh, made this unmanageable. And but I don't know all the details of that particular event, but just to highlight that concurrently associated with this weather pattern, these two extremes had manifest, and they're related to this particular pattern in the jet stream, as well as a deep plunging cold trough, very cold temperatures and near record cold in some places. In the down into Texas, while we had very high temperatures, near record temperatures associated with the ridge. So these extreme events can be connected by a large scale pattern, is the long story short. Sea level rise. This certainly factors in to the recent storms and the severe damage along the Maine coast for the December 18th storm, and especially the storms in January, in which timing of strong winds with high tide produced very damaging flooding. And I'll talk more about that in a few slides. But from data from Portland, from a tide gauge at Portland, going back to the early 1900s, the sea level has been measured to have risen about 7.5 inches. And so that's led to an increase in nuisance flooding in recent decades. And that happens in Portland and other places. So that has implications for coastal habitats, salt marshes. There will be salt marsh migration. And there's also concern about saltwater intrusion in drinking water supplies. And of course, erosion is a major concern, especially for the southwestern sector of the state, where the coastline tends to have more soft sediments. So now getting into 2023 year of extremes. These maps here show mean annual temperature on the left and mean annual precipitation on the right for 2023. And then now these maps show the anomalies. That is the difference between 2023 and a 50-year climatology, 1951 and 2007, 2000. And I've outlined Maine. So you can see that Maine, and also at the large scale, much warmer than climatology, and for us, much wetter than climatology, although there are other areas that were drier. Now I just wanted to run through a few interesting statistics of the past year. The statewide calendar year, January through December, second warmest and fifth wettest. First warmest January, so last January, and that is shown in this time series chart on the right. And you may recall articles that were coming out about mud season in January. Well, this January has been a little colder, and here in central Maine, there's the snow on the ground, and also north. But December was, of course, very warm, and there was a very late freeze up of the ground. And of course, with the December 18th storm, there was downpouring rain. So in all, we're having another very warm winter. Last winter was the third warmest December through February period. The first warmest July, although tied with 1921, 1952. But if we look at the minimum monthly temperature, the average minimum monthly temperature for July, it was the first warmest. And that is associated with overnight low temperatures are increasing more than daytime highs, because the atmosphere is more humid. Second wettest June, July, August period, near tie with 1917. And then the third warmest September, October, November, third warmest fall, tied with 2021. And again, first warmest minimum temperature for the fall. And overall, that season was very similar to 2017, including the very late killing frost. And finally, second warmest, fourth wettest December, which just concluded. Now this next piece of the slide shows, I figured I would show this. Gulf of Maine, last February and the January through March period was the first warmest. And here is the long-term time series relating the sea surface temperature time series across the basin, the Gulf of Maine as a whole. Now, later this year, in September, with Hurricane Lee, the impact of the winds churned up waters and brought some cool water from depth, and the temperatures in the Gulf cooled to more closer to average conditions, at least temporarily. But there's an interesting thing that can happen when there are major storms with lots of wind over ocean surfaces. Extremes, 2023, May, June, July, we had a lot of rain overall, a lot of cloud cover, and especially in May and into early June, there was a persistent pattern over North America that it would develop, might break down a little bit, but then reform. Now, this chart relates to a measure of the jet stream at what we would call 500 millibar height, so about 20,000 feet or so. It's diagnostic of the position of the jet stream. We can use it to identify ridges. So a ridge of warm air over Western Canada. And then there's downstream troughing. But I want to show this figure because if we take an average over this area, which again is diagnostic of the ridging associated with the jet stream, using climatology going back to 1940, this was an extreme 4 standard deviations above the mean. And there's nothing else like it in the record going back to 1940. This is from a what's called a climate reanalysis product that incorporates real world information. And now you may recall in the middle of May, on May 18th, there was a killing frost. That had a big impact on many crops and trees, including apple trees. And with this event, here's the temperatures, freezing temperatures in cool shades. And then in Old Town, there's a weather station that has both the 2-meter air temperature as well as the surface temperature. And so this was really interesting to see that for almost an hour, pretty close to an hour, the temperature dropped down to 22 degrees Fahrenheit. So big impact associated with that. And then in early June, again, associated with this large scale pattern, there was a stalled low pressure system over Maine and New Brunswick that developed. And you may recall the news headlines about the record poor air quality over New York City from forest fires in Quebec. Well, this circulation pattern brought us cloud cover and rain, and the counterclockwise rotation funneled the forest fire smoke to our west and south. But it was, again, all part of this extreme wave pattern developed over the continent. Record global mean temperature in July 2023. 2023 daily mean global temperature shown in orange. And here, the average for July shown in this map, the anomaly. And then a clip from NOAA with the headline in their confirmation of July being the hottest in observational record. And then here, I made this chart just yesterday. This has about a 1-week lag or so, but this is the signal for 2024 so far. Now getting to the storms, and I'm looking at the time. I'm going to try to wrap this up. A lot of text here. I'll just step through this briefly. December 18, January 10, January 13, in close succession, 3 very impactful storms. To get one of those would have been more than enough. So this was very unusual to get 3 major storms of this sort. Southeasterly storms, meaning bringing strong southeast winds, and very similar track in which the low pressure passes over the Great Lakes region and up into Quebec. And these storms, that particular track is a classic track for producing strong southeasterly winds in Maine. And impact to the electrical grid was comparable to that of Ice Storm 98. And I think initially more than half the state had lost power. Well, the worst flooding since the mid-1980s on the Androscoggin and Kennebec. This major disaster declaration made, and federal assistance was released. And of course, the impact along the coast from the high gusts in conjunction with high tide, major flooding, major structural losses and damage. And this item here notes that in Portland, with the January 13th storm, there's a record high tide measured, beating the previous record from 1978. These storms developed against a backdrop of a strong El Nino developed over the Pacific that's been influencing the weather, and record warm ocean temperatures worldwide, as well as across the North Atlantic. And we've covered most of the information in this slide already. Here, this map on the left shows mean sea level pressure in anomaly from long-term mean. But what I wanted to point out, here's the overall track heading north across eastern New York into Quebec. And then this is a high pressure pattern that had stalled because the storm had been moving a little more to the northeast, but this high pressure stalled, and the storm then veered to the north. And that particular pattern is what produced the particularly strong winds and the deluge of moisture, as well as very warm temperatures getting into the mid 50s. The temperature on the left, this is a December 18 storm, and precipitation on the right. These two animations are in sync. And there is that low pressure system heading right north, northward across eastern New York. And then the next slide shows the total estimated precipitation. This is from NOAA. It's called an analysis product. You can see most of the precipitation was in western and southwestern Maine, including some areas that saw over 5 inches. And there were some local spots that saw over 7. And that, of course, led to roads being washed out, and then the flooding on rivers and streams. The right panel shows the hourly forecast of maximum wind gusts. And one thing that was really interesting about this storm is that the period of gusts potential over 50 for about half the state was about 12 hours. The other two storms, the winds gusting over 50 only lasted maybe about 6 hours. And so that was one of the key elements that made the December 18 storm so damaging to the electrical grid, was the duration. Future storm trends, and then we're going to wrap this up. We are seeing more extremes. Maine's climate is getting wetter. And the studies that are available so far, utilizing both historical data sets and climate models, there is not yet a statistically significant increase in these damaging storm events. However, an analysis from 2020 finds that there is a statistically significant increase in more precipitation associated with these strong windstorms. The current studies available based on climate models suggest that strong cyclones such as this in the Northeast region could become less frequent but more intense. And I think more research is needed in that area, because we have just seen an increase in frequency, and in recent years there are other examples, and there may be deficiencies in the climate models in relation to the frequency of storms. It's a question mark. I think it requires more analysis and it remains it seems very likely that given the increase in extremes, that these impactful windstorms could become more common as well as more intense. But again, more research is needed. But these three examples here, uh, the uh, the October 30th storm 2017, again, some areas saw gusts approaching 70 miles per hour, large power outages. And then these are the two storms I mentioned in November. Oh, excuse me. Yeah. Oh, okay. This is 2019. The first one that occurred in middle of October, and then the second one that occurred in the very beginning of November. So I mentioned I wanted to end on a lighter note. I think we can all be proud of the action that's being taken in Maine through the Climate Council and also citizen groups and organizations. And so, although a lot of this information that I presented can feel overwhelming, one thing to keep in mind is that there is variability, and not every year is going to bring all these extremes. There will be some years that we could have major events such as what we've just experienced. Um, but I think through adaptation, through mitigation, and being focused on the positive things that we can do to prepare, I think it's important to keep sight of that and to not get too overwhelmed in considering all the things that can happen. Because if we're prepared, then if we're prepared for these extreme events and for the changing climate, then we'll be much better off, and that's what we should work towards. With that, I would like to say thank you. Be happy to take questions and also show you some resources on the Maine Climate Office website.
Thank you so much, Dr. Birkel. Oh my goodness, what a wealth of information. You have clearly done this before, so you know we're all feeling a little overwhelmed by it. So thank you for, for bringing us back to a positive note that we can take action. We are taking action, and we will continue to do that. And we've got lots of good questions. But before we get into those, I want to take a minute to remind everybody that you will get a follow-up email later this afternoon with the link to the recording of this program, and a couple of resources to help you keep exploring these climate trends, as well as an opportunity to share some stories. Personal stories are really a powerful way to document these changes that we're all seeing. And we would love to see your stories. By we, I mean the whole team at Maine Conservation Voters and also Dr. Birkel. So you'll find in that follow-up email a link to a form that will let you just share your story and then indicate, do you want us to send it on to Dr. Birkel? Do you want us to reach out and ask you questions and find out more about it, or you just want to get it off your chest and that's enough for one day? All of those are good options, and we hope you will follow that link and share some memories with us. We can't wait to hear. All right, let's get into questions. And actually, I might start with that one. Dr. Birkel, so many times, I feel like we've heard so many times, weather is not climate, climate is not weather. So will you just tell us how you think about those stories that we're getting ready to share with you? I'm sure the wheels are already turning. What am I going to share? How
Yeah,
did those sort of memories add up to a big picture for you?
I have one that yeah, I'll share a couple. And first, I mean, I would say that climate is average weather. And so, although for a weather event, we should treat it first and foremost as a weather event, there is this climate underpinning. And so we have to be careful about over ascribing the climate component, but the weather does develop over the current climate boundary conditions. And so there is this connection between the two. But one of the memories I have, I grew up in Bangor, and I was born in 1978. I have pretty decent memory up from mid 80s onward, and I can remember in 1992, shivering at the side of one of my friends that had a pool, and I'd go swimming over there in the summertime. And I can remember shivering beside the pool, and we were talking, well, why is it so cold this summer? We didn't really want to go swimming. Now, I had forgotten about that, but I learned about the Mount Pinatubo eruption about 10 years later and about the climate impact. For a couple of years, there was a cooling. And sure enough, the summer of 1992 was cooler than normal in Maine, and there was persistent northwesterly flow. It was cool, dry Canadian air, and it's not the kind of weather you want to go swimming in. And but I remember that. And so that's one related to a natural a volcanic eruption that caused cooling for a year. But also beyond that, I remember that the fall was it tended to be colder. Frost came earlier. First day of school, certainly in September. I remember we had to bundle up, certainly towards the end of September. It could still be a warm day, but I do distinctly remember that um, September seemed cooler. Now it's a lot more humid. August has gotten more humid, and in the data support that. So it's really interesting when anecdotal information, our memories, we can look at the data and it reaffirms what we sense. And I'd also like to mention one of the this I think is fun. Historical meteorology. Say if we don't want to, we want to take a moment and just think about history and Penobscot Bay. There's a beautiful record of Penobscot Bay freezing over in the early 1900s. There were 5 or 6 events. There are photographs. There are published stories of people driving uh, uh, cars at the time across the bay, across ice, including in 1918. This was during World War I, from Brooksville to Belfast. A gentleman drove a Ford Pathfinder 5 times back and forth across the bay to get supplies from Belfast. This was published in the Bangor Daily News. There's a photograph of the car with a sledge laden with supplies. And so that is fascinating from a historical perspective. And it also serves a contrast for today. But and on that note, I gave a talk at the Maine Maritime Museum a few years ago, and I figured, well, where this is the Maine Maritime Museum, I'll show slides of some of the bays and harbors frozen over and relay the story. And a gentleman came up after me afterwards, and he was a retired merchant marine. And I had talked about the last big freeze up occurred in January, February of 1934. And he came up to me and said, in the 1960s, in my youth, I spoke to the ferry boat captain out of Stonington, who said that in 1934, the ice was so bad that he could walk over the ice from Stonington to Isle Ho, and the ferry couldn't run for some time. And that kind of information, um, it's not recorded anywhere. It's just oral history. But it was that year, is that last really cold year, and that was the farthest out from the mainland where I could put a little data point where the ice was that bad. So those are my thoughts on the memories, climate related stories.
I have to confess that I had not really thought about the intersection of oral history and the such a data heavy I mean, your field is all about data and all of those incredible graphs that you showed. We've got lots of questions about the details of those too, but how do those, I'm just really fascinated by this idea of how such a data rich field intersects with oral history. And is it giving us that flavor, or is it actually how is it helping to contextualize those graphs?
I think it's very important, as well as indigenous knowledge and any kind of oral history, capturing events or phenomena that we haven't necessarily measured with an instrument, I think are very important. And another example, snowfall or snow on Katahdin and also on Mount Washington. And there's some interesting historical documents that have some pretty early, late season um, observance of snow. Uh, there could be stories related to ice fishing or the ice industry that used to exist in the early 1900s, up until I think it's up until about 1930s, 1940s, where lakes and rivers were harvested for ice for refrigeration. And um, and then even in written documents such as the Maine woods, Henry David Thoreau, is not necessarily linking to climate, but just the overall environment and how things have changed since then. There's this one passage where Thoreau is going up what was then called the Old Military Road, which is Route 2. My understanding is that was built during the American Revolution. And Thoreau is traveling up that road from, had crossed over at Old Town, and is heading up from Milford. Is making observation of at night, can hear wolves howling in the distance and see sign of caribou. And so this, I think, was the 1840s, as I recall. So just to capture the time and place. And so whether it's the surroundings or observations of the climate, um, yeah, and I think you could probably tell I'm pretty fascinated by history. I think it's great when climate information can be found in historical texts or orally. A lot of people, especially our elders, have stories of, well, when I was younger, we used to go ice fishing on the pond by 1st of November. Stories like that. I've heard a lot of those. And and also just that anecdotal information about how long snow used to last, and used to have real much generally a much more consistent snowpack throughout the winter.
I will confess that last night at dinner we were talking about the winters of the past, and my 16-year-old was reminiscing about how different it is since he was a kid. So if any of us want to feel old today, even the youngest among us are noticing those trends. And I think the data is so helpful to back that up and to say, no, you're not misremembering. Things are really different. Um, is that the combination of the data and the stories, is all of that being applied by the state? Or I guess I should say, how is it being applied by the state, you know, in the climate through the climate council process? Are we building for the future that we're experiencing now, or is there a gap there?
Well, I think the Climate Council is making a concerted effort to try to incorporate as much knowledge as possible from many different sources, and to try to build for the future that we expect. And based on the data, as that is also informed by local knowledge.
It's incredible. If you haven't had a chance, everyone, just last week there was a special meeting of the Climate Council to talk about the extreme storms, and you can find a recording of that meeting on the online. And Maggie, maybe we can add that to the follow-up. Oh my goodness, we have so many questions, and I'm going to resist the urge to get into. Many of you asked excellent questions to clarify some of the data and some of the terms. I'm actually going to ask two different questions. One about very real impacts here in Maine, and then one more connected to the bigger picture and current events. So our main specific question: what does this mean for maple syrup? Are we tracking that? I love March maple. What is it? Maine Maple Sunday in March. Is it always going to be in March? What's happening on that front?
That's an excellent question. Unfortunately, I'm not sure, but I have extension colleagues who would be able to answer that. And I would be happy to pass along the information. And I'm sure there are many questions that we won't be able to get to in the next few minutes, but I welcome people can send either if they send the questions to you or to me directly by email. My email address is birkel@maine.edu. It's BIRKEL at maine.edu. And if I get a flood of questions, I will answer each one as soon as possible. But certainly for the maple syrup, we have a specialist in extension who I'm sure would be able to give good insight on that.
Thank you so much, and thanks for being available to everyone. Um, Zooming out and looking at the other coast, all of this news that we're seeing about the atmospheric rivers and extreme weather shift in other parts of the country, and what are those explainable by the models that you walked us through today?
The models that project into the future, in general, and it's associated with the intensification of the hydrologic cycle. And the atmospheric rivers relate to a circulation pattern that funnels a ton of moisture into one region. They're most common on the west coast off California. And it depends on a definition. There are specific thresholds that are established in the literature in ways for defining what would qualify as an atmospheric river. But when we look at the December 18 storm, we call it the precipitable water, the total amount of water in an column of atmosphere that could precipitate as rain. That's a diagnostic measure. And that the December 18 event might qualify as an atmospheric river. Again, I would have to check the specific thresholds, but it was a very intense plume, hence the extremely unusual amounts of rainfall in mid to late December. But and there are other examples too, where a similar very late season plume of tropical moisture produce a deluge here that may or may not qualify as an atmospheric river, but has similar appearance and qualities.
Thank you. It's one of those phrases that now that I've heard it, I'm hearing it everywhere and not really did not really know what it meant. So thank you very much. And maybe we've experienced something similar here.
And they develop with the juxtaposition of a low and high pressure, a low circulating counterclockwise, high clockwise, in certain patterns can produce a really intense plume of moisture in relation to the circulation of the high and the low. And so it's associated with the storm and then how it may come up against a high pressure.
Thank you. One last question before we let you go. What do you recommend for people who are feeling like, we have got to plan for this. We've got to build back more resiliently. How should people register that concern and that interest? Reach out to the Climate Council, or is there somebody else we should be reaching out to say, hey, this matters?
Well, I would seek out citizen groups and potentially reach out to the Climate Council, attend Climate Council meetings, and write your representatives, and find others in your community who may already be involved in groups. And I think there are many different ways, and I do think it's important to try to stay positive, and because again, even though when there is especially with a series of storms like we just experienced, it can be very stressful, and some people's homes were damaged, businesses damaged. Um, but when we think of in the years ahead, again, not every year is going to bring such extremes. There will be some, but there's still variability. Um, looking out later into this year, it's there's a question about the current strong El Nino is forecast to diminish over the next few months. And so we'll probably be at ENSO neutral conditions that's over the Pacific by somewhere between April and June, the current projections. That would at least, that should lower temperatures, but we'll see. I don't know if that fully answers the question, but
It is a great place to start, and thank you to everyone who is sending messages through the chat right now saying, I've got an idea, you could join here, you could get involved in
Great.
this. There are so many people who are doing this work, and you can count on us. If you have questions, if you're looking for places to plug in, please do reach out. Thanks to all of you for being in this reality and this work with us. And thank you so much, Dr. Sean Birkel, for sharing your work and a scientific perspective on the realities that we're all experiencing. We will be back in this space next week to see how Maine farmers are adapting to this changing climate. We'll have Shelley McGuire, the Policy and Research Director from Maine Farmland Trust, and Dave Colson, who is the owner of New Leaf Farm and the Northeast Region's farmers representative to the National Organic Farmers Association. There will be more information about that program and a link to register in this afternoon's follow-up email. We hope to see you all next week. And until then, have a wonderful weekend and take care.
Thank you.
Thank you, Dr. Birkel.
You're very welcome.